Hi, and welcome to Build. Thank you for joining us virtually for the session on increasing data science, efficiency, security, and privacy using ML operations in Azure Machine Learning Service. My name is John Wu, and I'll be your moderator for this session. As you can see, we have a dedicated area for you to ask questions, and we encourage you to do so in order to keep this interactive. I'll bring up some of the questions for the presenter in the Q&A in the later half of the session. So without taking any more time, let me invite Ashish Pateja and Jordan Edwards to drive us through the presentation. Ashish, Jordan, the floor is all yours.
Hey, hello everyone. Welcome to the build. Thanks for joining. My name is Ashish Pateja and I'm a program manager on Azure Machine Learning. And specifically, I look into enterprise readiness and provisioning of Azure Machine Learning. Jordan.
Yeah, thanks, Ashish. Hey, everybody, welcome to Build. I'm Jordan Edwards. I'm a program manager on the Azure Machine Learning team. And I work on how to bring your ML workflows to production with what we call MLOps. So we've got a pretty packed agenda for today. I'm going to start by giving a overview and primer of the machine learning platform that we provide on Azure. Then Ashish is going to talk about how to lock down, secure, and configure that machine learning platform so that you can use it inside of your trusted enterprise environment. And then I'm going to walk through how you can use that secured lockdown workspace to do reproducible model training and to automate the end-to-end ML lifecycle. So I just sort of continue onward from there. When we talk about the machine learning platform on Azure, we see it as consisting of the following components. So on the top, you have different experiences for data scientists. So we have a Python SDK, a command line interface, a drag and drop designer UI, as well as integration with the development environments that are most common amongst data scientists, like Visual Studio Code, Jupyter Lab. We also have these MLOps capabilities that help you with managing all of the assets in the end-to-end machine learning lifecycle. So keeping track of your code, your data, your environment configurations, all of the experiments that you're running, all of the models you're producing, and all the places where those models are actually running. And then, of course, you also have the fundamentals of compute, storage, and orchestration services under the covers that make all of this possible. So that's the workspace construct. Now I'm going to hand it off to Ashish to talk about how do I take this workspace construct and secure it and lock it down.
Thanks, Jordan. So the very first thing an IT admin has to do before you can start using Azure Machine Learning is to provision this Azure resource called Workspace that is needed to get started with Azure Machine Learning. And in order to provision the workspace and all the associated resources that a data scientist would need for end-to-end machine learning in a secure way, a data scientist typically an IT admin typically starts with Azure Portal, which is kind of an IT admin tool for an admin to provision the workspace. Or an IT admin can even use something like ARM templates or REST APIs in order to automate that provisioning workflow. Now, while provisioning a workspace, IT admin makes sure that all the security controls are in place. For example, to be able to enable private link or virtual network for workspace so that workspace is accessible only from that virtual network. To enable encryption with customer managed keys, to enable role-based access controls. A good example of that would be an IT admin might want to assign certain role to a data scientist, whereby a data scientist can, let's say, run an experiment or deploy a model, but won't be able to create a compute. And we'll see that in the demo in the next slide. Also, an IT admin would also configure associated Azure services, which are automatically created as part of Azure ML workspace creation. Having said that, all these Azure services, they all follow good security practices that Azure provides. For instance, you can put all the storage, key vault, and container registry behind the VNet as well. Now, once all the provisioning is done in a secure manner, a data scientist can be most productive and can start using ML Studio for model development. Now, in order to do model development and deployment, a data scientist can use compute instance, which is the cloud hosted way to access Jupyter notebooks. A data scientist can run training on a compute cluster which can be a set of a CPU or GPU based clusters, depending on the type of training data scientist is looking to run. Once that model training is done, model can be deployed on the AKS cluster, and this model, the scoring endpoint that we call it, can be deployed even on a private IP. Now, what that means is, if the model is deployed over a private IP, that means this scoring endpoint is accessible only from within the enterprise or within the virtual network. And all these computes that I talked about here, whether it is compute instance or compute cluster or AKS cluster, they are all managed computes. You don't have to worry about it. Microsoft just manages it for you. Having said that, you can still bind them to your specific virtual network. That way, they are accessible only from your enterprise network.
Got it. And so how do I actually go about getting my data inside of the virtual network and attached to the workspace?
Yeah, so the data box that you see on the left top of this diagram, that is the data a data scientist would use to train the model, for example. Now, this data can come from a bunch of data stores that AML supports, for example, Azure SQL DB or Azure ADLS Gen 2, for example. And all these storages can be bind to uh, the same virtual network, or you can enable customer managed keys encryption on them to get to all the good security practices there.
Got it. Cool.
So on this slide, I'll be walking through a demo. So I'm starting with our public documentation and showing off a few ARM templates that we'll use to provision the workspace in a secure manner. Now, these ARM templates can be used to secure the workspace to use things like customer managed keys or private link. Here I'm showing this private endpoint, which is an endpoint that you initiate from your virtual network in order to link to the workspace, which means the workspace would be accessible only from that virtual network. Now, this is where we are seeing Windows Terminal and seeing how we run that ARM template. And I'm showing all the parameters here that we use to run the template. And once this template is run, as you can see, we provision all the associated resources in a secure manner. I'm again showing private endpoints here. You can even enable customer managed keys. Like ARM templates is kind of your one-stop shop. You use just one ARM template and make sure everything is secured in a secured way. Everything is provisioned. Now, this is the resource group in Azure portal, where I'm showing all the resources that we have provisioned. This is the machine learning workspace. There are a bunch of associated resources, and I'm also highlighting all the private endpoints and private DNS zone. Now, as you can see with the private endpoint, all the communication from your virtual network to workspace is happening over a private IP. And that's what we are showing here as part of like DNS zone and private endpoints. Now, once all that is done, a data scientist, an IT admin might also want to create role-based access control, as I was showing in my previous slide. Now, this is a JSON where I'm defining this is my data scientist role. These are the actions my data scientist can do. These are the actions data scientist cannot do, and at what scope this role is assigned. And as you can see, one of the not action part was there. I do not want my data scientist in this example to be able to create a compute cluster, for example. Now I'm back to our public documentation where I'm showing how you can actually create this custom role. Remember, we had that JSON that we saw on the VS Code. And now I'm showing that with this one command, you can actually create the data scientist role. Once that role is created, if you remember, we assigned the scope to AML workspace. I'm on the workspace right now. And under the access control section, I'm showing off my live ID here, which is the ID to which I've assigned this role to, the data scientist role. Now, I've logged into ML Studio with my live ID. And if you remember, one of the not actions I've specified here is that I don't want this particular role to be able to create a compute. I'm looking to create a compute cluster right now. I specify all the required fields here, maximum number of nodes, everything, and try to create. And obviously I cannot create it because this is what my IT admin has restricted me to. And this is just one example. An IT admin can restrict on deploying a model or creating a data set and so on and so forth, bunch of functionality across AML. And now this is one example whereby how you can put an associated resource, in this case storage account, behind a virtual network. And you can do same for Azure Container Registry and Key Vault and so on. Now, once all that is done, you have all the associated resources and workspace bound to a virtual network, right? Now I can go to ML Studio, and as I create, let's say, various computes, if you remember from the previous slide, I can put each and every compute behind a virtual network as well. So once that is done, once I put my inference cluster or compute instance behind the VNet, I have an end-to-end secure way to start doing ML now. Now, once all that is done, now I'm switching back to a VM. Think of this VM as my workstation, which is sitting in my enterprise in the same virtual network. Just to show this thing, we are back to Azure portal. And as you can see, this VM that I'm going to use for the demo sits inside that virtual network. Now I'm back to the VM. Now as a data scientist, as I switch back and forth between data sets, experiments, pretty much any ML functionality, I can use all of that. But if I'm outside of the virtual network, where I should not be able to access all this, and if I try to access experiments, data sets, try to run an experiment or deploy a model, I won't be able to do that because that's the whole point, right? I mean, we have a network layer of security if you're looking to access any EML functionality outside of the virtual network that you are in.
Got it. So basically, if I'm outside the virtual network, I can't get access to any of the data that's stored inside of the workspace.
Exactly, yeah. This is just to enable end-to-end machine learning in a secure manner without causing any friction for the data scientist so that IT admin can handle all these settings. Yep.
Got it. Cool. Thanks, Ashish. So now I'm going to take back over and talk a bit about what we view about the ML lifecycle and the end-to-end model development process. So when we think about the ML lifecycle, it's really about bringing together these different personas to help use data to train models, to take those models and embed them into your applications to add business value. And that means bringing in these three different personas. So you have data engineers who are responsible for taking the data in your data lake, shaping it, making it useful, so the data scientists can build models on top of it. You have data scientists who are taking that data, featureizing it, trying different algorithms, sweeping different hyperparameters, trying to find what fits and what works well. And then when the data scientist has a good enough model, they'll push it to the model registry. Now, when it hits the model registry, your ML engineer or the person who's responsible for making sure that your model gets deployed out to production or used wherever in whatever data pipeline it's trying to get used inside of will then set up the process to package, validate, deploy, and monitor the model. And then those monitoring signals are used to indicate when you should actually go ahead and retrain the model to replace the one that's currently running in production.
Hey, Jordan, can you talk about what are some of the signals or the triggers that I would use to retrain my model?
Yeah, so when it comes to model monitoring, there are a few different signals you can look at. One is, of course, is the model working successfully or is it throwing errors when the inputs come in? Another is, are the inputs to the model changing or drifting over time? So, say your data has some seasonality to it, month over month or quarter over quarter, the shape of the data has changed and your model is no longer able to predict accurately. So our drift monitoring service is designed to help solve those types of problems. And then you can also just look at, from the business application that's using your model, say you have a recommendation system, are users actually clicking on the recommendations that you're providing to them? Are they clicking on maybe not the top recommendation, but one of the other ones, or are they ignoring your recommendations entirely? So the combination of, is the model behaving well from is it crashing or not? Have the inputs to the model changed over time? And then is the model adding business value to your users? So those three signals you can use to figure out when you would want to go and retrain a model.
Cool, thanks.
Yeah. So now I'm going to do a little demo. And we're going to go back to the same machine learning workspace that Ashish was showing off earlier. So inside the workspace, as I mentioned, we have all of these MLOps capabilities to help with managing all of the assets in the end-to-end ML lifecycle. And so in this case, here's a list of all of the different data sets that I've registered. So think of this as being, when a data engineer puts some data in the catalog, I can then pull it in and make it really easy for data scientists to consume when I'm going and training a model. Right, so I look here at, okay, here's this nice diabetes data set. Here are the files. It's actually put into that same storage account that's managed with the workspace behind the virtual network. the files, the size of them, and then we try to make it as easy as possible to pull that data in. So you can download the data, you can mount the data inside your training jobs, and then you can also take your data and transform it into pandas data frames or other formats that your data scientists are comfortable with for building models on top. But the sort of the secret sauce when it comes to training the machine learning models is our run history view here. And so if I look into this, these are a list of all of the different experiments that I've executed on the machine learning platform or outside of it, so you can track from anywhere. And if I click into this, then you'll actually see we capture all sorts of different metadata about the run. So, did it succeed or fail? When was it created? How long did it take to run? What compute target did it run on? What script did I run? Who created the run? What data went into this training job? And then what models were produced by this run?
So basically, I can use this data set and whatever script that is used by a fellow data scientist to reproduce the exact same run, right?
Exactly. So you can just resubmit the run as is to make sure you get the same result, or you can go in and modify certain things, right? So if I click into data sets, you'll see here, this is a globally unique identifier, but it's that same registered diabetes data set that I showed you earlier. When it comes to the compute cluster, same compute clusters that Ashish was showing off. When it comes to the script name, so if I go over here to the snapshot, we actually take a copy of the code every time you go and run the training job. If you're coming from a Git repository, we also record all of the Git info, but this is our way of guaranteeing that as you keep experimenting, we have a copy of the code so you can reproduce it. And so here's all of the code. When it comes to the outputs and logs, so we actually capture here all of the information which goes to standard out. So these are statements that I was printing inside of my training job, and they all just get streamed out nicely here. Now you can see this in the studio. Also, if you're using something like Jupyter or VS Code, this will all stream back directly into your development environment. Then we also keep track of here when it comes to the different metrics. So all the metrics that are stored are uploaded to our run history service and plotted to make it easy to consume. And then, of course, we also keep track of the models, right? So when it comes to the model, I can go over here to the model. I can see the version of it, what framework version. Again, that lineage back to the run that it came from, the endpoints that are deployed using the model, the artifacts that are inside of the model. And then when I go to deploy it, I can just say, here's my diabetes AKS endpoint, pick the compute type that I want to deploy it on. And then for AKS, I just pick the compute cluster. And you'll see here it says no code deployment. That basically means I don't need to give you anything else besides the model, and it's good to go. And then you just hit deploy, and it will go ahead and take that and deploy it out to the cluster. Now, we talked about, so this is sort of how you can deploy directly from the Studio UI. This also works from the Python SDK and the command line interface. But what I've done here is actually wired all this up into an Azure DevOps release pipeline. So in this case, there's 3 different artifacts. I'm actually taking a machine learning model, an explanation for that model, and some code to go along with it to handle my pre and post processors, and wiring up my continuous deployment pipeline so that whenever a new model comes in, the code surrounding it stays the same, but we just update the model in place and deploy the new model out to test in production. And if I click into these individual phases, you'll see the steps that are actually going and running here. So if I go into here, and all this is doing is going and executing the model deployment task. And so it's just going to run the CLI command, and you'll see here, AZML model deploy. Great. And then you'll see, okay, it was successfully completed. Here's all the information about where it came from. And then you can, again, see where, the URL that it was deployed to. So that's how you can set up automated deployment from Azure DevOps. I also wanted to show off how you can wire this into Azure Event Grid. So here's that same machine learning workspace. I have all of these event subscriptions already set up, but it's pretty simple to build, customizable workflows on top of any events in the ML lifecycle with Azure Machine Learning plus Event Grid plus Logic Apps or Azure Functions. Logic Apps for the purposes of this demo. So all sorts of different event types that you can build on top of. When it comes to the specific machine learning events, we have, okay, there was a data drift detection, a model was deployed, a model was registered, a run completed, or the status of a run changed. So say the run failed. So in this case, I'll say, okay, great, the run completed. Now what do I want to do after that? Now, the first example I showed you was just using an Azure DevOps release pipeline natively, but there's all sorts of different built-in actions that you can take. Like I could create a release, or I could create a work item. I could also just, list different things out. And then when it comes to, say I just want to send an email to somebody to take a look, same thing supported here. So there's all these different built-in activities for Office 365. And then if I want to wire this back into my data pipeline, then there's built-in integration with Azure Data Factory as well. So I can just create an Azure Data Factory pipeline run to help complete that circle, pull in fresh data, and then go and train the model on top of it. So that was a quick walkthrough of the ML lifecycle for reproducible model training and then automating the lifecycle. Now, bringing it back, we talked about the machine learning platform. Ashish talked about how to configure it, secure it, lock it down. And then I showed you how to use it once it's configured and secured to support the end-to-end ML lifecycle. And with that, I'll hand it back to Ashish.
Thanks, Jordan. So key takeaways from this presentation are: an IT admin can provision an AML workspace using Azure portal or ARM templates in a secure and automated fashion. From there on, a data scientist can be most productive inside AML Studio, where we manage all assets of the ML lifecycle. Back to you, John, for any questions.
Thank you, Ashish, and thank you, Jordan, for putting on an excellent presentation. Also, I'd like to thank the audience for submitting tons of questions during the session. We have about 5 minutes for Q&A, so we're going to try to go through as many of these questions as we can. So start with the first one here. This one will be for Jordan. Azure ML has Spark support. It also can connect and work with Azure Databricks. Which one do you use?
Depends on the scenario that you're trying to solve for. If you're already using Databricks, you can wire it into Azure Machine Learning. You can also, from Azure Databricks, connect to our MLflow compatible API when it comes to run tracking and model registration. But really, when it comes to the Spark compute you're choosing, it just depends on what you're already using in your enterprise and what your company is comfortable with.
Cool. Thank you. Next question, also another question for Jordan. Where does MLflow fit into MLOps in Azure Machine Learning?
So going off of the last question, Azure Machine Learning is fully compatible with the MLflow APIs when it comes to run tracking, and we're adding support for the MLflow model registry right now as well. So basically, think about Azure Machine Learning as a hosted MLflow platform that's open, interoperable. You can use it from anywhere. It has no tie-in to you must be running it from Spark, for example.
Cool. Next question. I have a question about AML. If we use Kubernetes consisting of 3 NT6 machines, so 3 nodes, as a computer destination, is it possible to deploy 4 services that use GPUs, or does each service block a GPU on that Kubernetes service or cluster? I guess, Jordan, this is another question for you.
So for currently, when you deploy a model out to Kubernetes for inference, it will use up the full GPU when it's running the inference workloads. We're working with the Kubernetes team to help smooth out and streamline that experience so that you can, for example, share the GPUs, but it's probably going to be a while before that's fully lit up in the product.
Okay, cool. Thanks. More questions also for you, Jordan, because they're all related to MLOps.
Sure.
How does Azure ML work with Git?
So today, whenever you submit a run or register a model, deploy a model, we look and see if you're doing those commands from a Git repository. And when you're doing that, we actually will log the repository, the branch, the commit, and whether or not the repo was dirty. So what that lets us do is give a clean lineage where you can go back and figure out exactly where the code came from. Now, what we're working on in the next 6 to 12 months is being able to actually pull code directly from the Git repository to run an experiment. So expect more cool news to follow on the Git integration side in the next 6 months.
Okay, that actually kind of leads us into the next question, which is, what are artifacts?
Got it. So artifacts are today the underlying files that back the different asset stores that we have in Azure Machine Learning. So whether it's a data set or an environment or a run or a model, they're all backed by these artifacts, which today are stored either in workspace managed storage, or you can, as we mentioned when talking with Ashish, you have these attached storage accounts. And so the artifacts can come from attached storage accounts or from workspace managed storage.
Cool. Another question. Once again, these questions keep going to Jordan. So, but Ashish, feel free to chime in if you want to add some more stuff to it. On what factors should our choice of AKS or ACI depend on?
Excellent question. Depends what you're trying to do. For production workloads, we recommend AKS right now. The authentication story is better. The auto scaling story is better. However, if you're just looking to get something started quickly, then ACI is a great story for dev test. We also have in preview integration with App Service as well as Azure Functions. But really, for doing production inference workloads, our recommendation is AKS.
And thank you. And I just want to add a couple of more things on that on security that Jordan touched upon. So definitely with AKS, we have a better security story. For example, the thing that I briefly touched upon in my slide, that when you deploy a scoring endpoint, you can do it over a private IP on AKS, for example, right? And also with AKS, also we give another variant of dev test. If you want to provision a single node AKS cluster for dev test, you can do that as well. And that way you can stay consistent between your dev test and production environments with AKS.
Thank you, Ashish. And last question, we have about 3 minutes left, so we'll call it after this question. What platform or service is model monitoring done on? Can it be done on Power BI?
So when it comes to model monitoring today, it's really just a job you set up to run on 2 data sets. And the outputs of it are actually just emitted as a CSV file. So in theory, you can just take that CSV, pull it into Power BI, and build your own dashboarding on top. But today, our sort of built-in native flow is it's wired into Azure Monitor, and you can build alerts over there. But yeah, you can totally just wire it up to Power BI.
Awesome. Thanks, Jordan. And once again, thanks to Ashish for putting on a great presentation. This is all the time that we have for now. Also like to thank everyone for taking part in this session. We hope you were to gain some value out of it. As you can see on the screen, we have a long list of other AI sessions that are going on. Some of them have already occurred and some of them have yet to happen. And we invite you to please join into the ones that you're interested in. As for now, that's all we have for you. Thanks for listening, and we hope you enjoy the rest of Build.
Thank you.
Thank you.